All right, this video I'm going to cover the 6.4, the set. Just going to talk about these diagrams in relationship to the work that we were to do the other day. And then I'm going to do my best with the diagram here for 6.5, the task. And I've got it displayed on the overhead. If I need to, I'll draw the whole thing out and you can be able to see it. But I just got to check and look and see how it is with the projector on and the lights off and all that. So we'll come to that in a second. The gist of what we discussed the other day in the previous video was that if we have parallel lines that don't cross, again, this example, I don't really like it for the fact that they didn't label it very well. When we talk about the task, I'll show you what I mean by labeling of lines. I'll reiterate that again. But if you have lines that don't cross, two or more of them cut by transversals, then these segments get divided proportionally. So we created a ratio that said A over B was equal to D over C, and we needed to create a third ratio for that. This one is tough because it doesn't label the vertices, which are the intersections, so it's kind of hard. But when we look at this, we talked about the distance from line to line here, which was A, from here to here is B. The other ratio that we get to create is the distance of A plus B. It's easier if we said 2 and 5, because now we could say 7 over whatever D plus C would be. So that was a tough one. It'll make more sense when we start seeing some more, and we can make that relationship and add them together, especially if we look at the diagram that we will see in the task. Over here, we kept this simple. We said DE because it doesn't have numbers, again, for each of the segments. So we compared DE over FG, CD over AF or FA, and if we just continue that trend down at the bottom, it's BC over BA, or CB over AC, and it's segment. All right, so that just continues the pattern there. So that would follow us down to question number 9. I can already tell I'm going to get a bright spot from the projector. That would follow us down to number 9. We created this yesterday, okay, or in the previous video, where we compared 2 over n to 5 over 6.5. I could have compared 2 over 5, and if I did that, I would have had to have said n over 6.5. Either way, when you cross multiply, guess what you get? You're going to get 5n and 5n right here. So it's going to work out to be the same. Now, I asked the student, okay, I didn't do it is what they said in class. I said, okay, well, if you're taking a multiple choice test, look at the obvious here. What would be a reasonable answer for a value for n, based on the fact that this is 5 and this is 6.5 and this is 2? And the student said 3. 3 would be probably logical. Yeah, I would agree. 3 would be reasonable. If you do the work here, you get, I believe, 16, or was that was a different one. That was the last one, which is number 10, I believe. You get 16 over 3. This is 5 times 2 is 10, 12, 13. Okay, so that's 13 divided by 5, which gives me 2.6. Okay, so 2.6 is the answer for this one. The next one was 5.3. All right, you're not going to see, and it was 16 over a number. All right, I want to say it was yeah, it was 16 over 3. You're not going to see 16 over 3 as an answer. Okay, you can't leave your answer as that. You've got to reduce them. And then the last one, which actually I can go back over here now and get rid of. Sorry, I hope you don't get dizzy with the camera. I can get rid of this diagram. The last thing it said was, hey, make statements. I want statements of parallel lines, and I want statements of similarity. Right? So here's your diagram for number 11, and then here's your diagram for number 12. It looks something like this. Okay, you had B, A, C is a common angle. You had, I think it was D, E, and F, and G. I think it was similar to that. I don't have my paper in front of me. All right? But over here, obviously, these two lines are parallel. So we had A here again. I think this is BC, and DE. Again, forgive me if the letters aren't correct, but we're going to say that BC, segment BC is parallel. Again, use your symbolism, physically write it, to segment DE. Those two lines are parallel. And then we're going to say triangle ABC is similar. Use the symbol for similar, right, to triangle ADE. Right? So there's number 11. Number 12, obviously the lines are parallel. I have three that are parallel. So BA, again, forgive me if the letters aren't correctly, but you get the idea. BA is parallel to segment DE, which is also parallel to segment FG. So you're going to have three. You have three lines that are parallel. I have one statement that's parallel right after another. And then you'll have how many triangles? Well, I have the large one, the medium, and small. Again, be consistent. That's what a student in my 5th period class did yesterday. They were consistent in what they did. Triangle BAC is similar, again, use that similar statement right here, or symbol, to triangle DEC, which is similar to triangle, because they're all similar, right? I can say the first one is similar to the third one, the second one similar to the first one, the second one similar to the third one. I can do that. And it's triangle FGC. All right, so there's that. Now I'm going to move into the diagram. And this just is, I'm going to have to make the best of this, because this just is not going to really want to seem to work. Now, hopefully, this becomes a little bit better as I go through and shut this off, and you can see it a little bit better. If I can't here, I'm going to go ahead. That's a little better. But you have the diagram in front of you. You can see there is one line, a transversal right here, and there's another one at the top that is that's parallel. Now, the thing I stated that the previous diagram didn't do is it didn't name the lines. If you look on the left side of your paper, P, Q, R, and S, there are your lines. Now if I want to talk about lines being parallel and I say line P or line Q, or line P is parallel to Q, you can look at these two and see. All right? Or P is congruent to R, P is congruent, or parallel, parallel to S. You can see which lines we're talking about. All right? And you know what? I think I'm just going to go ahead and do this, because even though this isn't exactly great, I'm going to continue this, because I just don't think you'll like that bright light in the board. And I can use this for my next video as well. All right, so here's what we're given, and we're given that this segment is 12. I got 10, I got 12, I got 12, I got 3, 4, 33.7, 21.6, and am I missing anything? I'm not missing anything at all, except I do need to get rid of these because my diagram is off just a little bit from yesterday, and that's what we're given. Okay, so I'm going to shut that off and turn the lights back on, because I think you'll be able to see it better. What's the gist of this? Well, a lot of you look at this and you see just kind of splatter all over the place. You're like, Mr. Wilson, I see a bunch of lines. This doesn't make sense. Well, what they're getting you to see is they're getting you to see the relationships of all the stuff that is going on that we've kind of discussed. All right, and I forgot one line, and that one line, it's important. That one line goes right here. Okay, that's important because actually I think it just goes to right there. Okay, so I drew too much. Right? That's important because when we look at this, we want to talk about our parallel lines and transversals, because we have parallel lines, we have two transversals that are cutting across this. We've got a lot of things that are going on. And when you look at this, focus on something. Pick something and roll with it. So where I started this is I started this right here. What do I know about this figure? What I know about this figure is it's a rectangle, and I know that opposite sides of a rectangle are congruent. So I'm going to label the top 18, I'm going to label the left 12. Opposite sides are congruent. It also tells me that one angle down here is 90 degrees. So if one angle is 90 degrees, guess what? all four angles of this rectangle are 90 degrees. That's how I identify it as a rectangle. That means that this triangle over here is a right triangle. Now, I know all the angles and all the sides of this rectangle. I can move on to a different figure, regardless of where I move. If I move over here to this triangle, and I want to try and find sides, yes, I know it's a right triangle, but I only know one of the three sides. So that doesn't really help me a whole lot. I move back over here to the triangle on the left. I know it's a right triangle, I know two of the three sides, and I know an angle. How do I find this third one? I find the third one by saying, hey, gee, 180 is equal to 53 plus 90 plus x. And I'm going to go ahead. So doodles right here. Pause a second and see if you can find the measure of that angle. All right, you came back, you should have found 37. All right? Now, if you found that angle is 37, in order to complete the angles and sides of this figure, I have to find the hypotenuse. Well, if I know two of the three sides of a right triangle, how do I find the third? Hopefully you said Pythagorean Theorem. Well, what's the theorem? The theorem is not a squared plus b squared equals c squared. Although, that is the formula that you use. Remember, the theorem, it says, hey, if I take the legs of a right triangle and square them and add them together, that's equal to the hypotenuse squared. You have the formula, okay? And if this looks confusing to you, draw the figure off to the side. 9, 12, 53, 37. Now, find this. That's C. Pause and find it. Okay, now that you're back, or did you pause it? You probably didn't pause it. Seriously, pause and try and find it. Make an attempt at it. You should have gotten 15. Now I know all the angles and all the sides, and it just goes from here. I'm not going to do all the rest of this. We got about 2 more minutes, I think, and I'll be done if that. All right? When you look at this and you progress up, because you can find all these, you will probably need about 1 or 2 more doodles like this, and you'll know everything else. Why is that? Because the rest of this is filled with alternate interior angles, corresponding angles, vertical angles. It's filled with a lot of things. Go back. That's why it's important that we know this. Right? When I look at this triangle here, and I look at these two angles right in here, these are what we call same side interior angles. Same side interior angles are supplementary. So if I know this angle, I can find this angle by subtracting 180. Or if I know this angle, I can know this angle by subtracting 180. Well, hey, what do I know about the relationship of this angle and this angle? Two parallel lines in here. This is what you have. You have a diagram that looks like this. If you need to separate it, draw it and separate it. You have one that looks like this. What do I know about these angles? Well, go back to 5.5. What you should go back and recognize is that they are on alternate sides of a transversal, and they are both inside my parallel lines. Alternate interior angles. What did we discuss about alternate interior angles? Alternate interior angles are congruent. So that means this is 53 degrees. Well, gee, 180 minus 53 is equal to, pause it, and figure it out. Because these two, I told you, are supplementary. 53 minus 180, what do you get? You get 127. Now, what's the measure of this angle? Well, what's the relationship between these two? They're directly across from each other. So now I'm talking about angles that are directly across from each other right here. Go back to 5.5. We talked about it. They're vertical, so this is 53. Now, I'm going to change things a little bit. Okay? I'm going to talk about this angle and this angle, because that's this 53 and this angle right here, or this angle and this angle. So what do I know about these angles right here? What you should be saying is that they are 53 because of corresponding angles. One inside, one outside of my parallel lines. You see that? You see that? So now that I know that these are corresponding, 53, 53, what's this angle? Same thing down here. We had vertical, vertical, vertical. And now I'm just listing a whole bunch of different things about all of these. Now, also about sides. One other thing about sides. And then we're going to be done. This segment between R and S is 12. The triangle, the side of the triangle that we found, was 15. Okay? This segment I don't know, but this segment is 12. What's the length of this segment right here? what's a logical answer for this? If I compare across parallel lines, which was the idea that they wanted us to get over here, that they're proportional, 12 over 15, 12 over 15, better be equal to 12 over what? This side has to be 15. Okay, thinking logically about it. You need to find, you do not need to find, do not need to find the segments that I'm going to star. So you don't need to find this one, and I believe it was this one, or this one down here. You don't need to find those, but all the other angles you should be able to find. All right, that was the assignment. Okay, go for it. We'll see what happens in the next episode. Sorry for the long video.